Good afternoon, my YouTube viewer. Basically, what we're going to do is we're going to do a practice question on confidence intervals. So you have a sample of 50 students' test scores with a mean score of 75 and a standard deviation of 10. Calculate the 95% confidence interval for the population mean score. And then hint, since the population standard deviation is unknown and the sample size is moderate, use the t-distribution. So you're already being told to use the t-distribution on that. So that's good. You don't have to figure out what distribution to use. So the mean is 75. The sample standard deviation is 10. The sample size is 50. Confidence level is 95%. Standard error is B7, that's 10 standard deviation divided by the square root of B8, that's the sample size. So your standard error is 1.414. Degree of freedom is 49 because it's B8, 50 minus 1. Your critical t-value is t because we're using the t-distribution. The inv.2t, 2t indicates it's 2 tails, brackets 1 minus b9, so that's 1 minus 0.95, comma, b11 degree of freedom. And that gives you a critical t-value of 2.009. Your margin of error is B12, that's your critical t-value, times B10, that's your standard error, so that's 2.84. So your lower bound confidence interval is 72.158, and your upper bound confidence interval is 77.841. And then what we've done is we have created a distribution so you can see the confidence interval on a normal distribution. And the reason why we do it on a normal distribution is because a normal distribution is very similar to a t-distribution, and it's just not really feasible to get this graph to work on a t-distribution. So we give our x value is 50 to our x value is 50 to 100 and half a degree and half a point intervals. So we've got our lower bound 72.158 and our upper bound 77.84. And the y value for the line height is normal.dist brackets B6, which is the mean, comma B6, which is the mean, comma B7, which is the standard deviation, and false, meaning that it is the probability PDF probability distribution function. But the y value for the line height, if you can't get that, if it's just too much and you can't get it, then just pick the highest height that you want. So it would be 0.04. Okay, so let's say you just can't get the y value, and just eyeball it on your graph, and on your graph it's going to be a 0.04. So now your x value is going to be 72.158 at 0, and it's going to be 72.18 at 0.39, 0.039, and then your upper bound is going to be 77.841, 0 at 0, and 77.841 at 0.039. So you've got your normal distribution in blue, you've got your lower bound in orange, and you've got your upper bound in gray. And so if you want to see what we did, we've actually got 3 charts in one, and we've applied all 3. So you've got your y is your normal distribution, gray is your upper bound, and orange is your lower bound. And it took me a long time to figure out how to do that. But if you want to make your own chart in Excel, you can lay 3 charts on top of each other, which is basically what I did, and it took me a long time to do that. But you can figure out how to do that. I personally use Copilot to teach myself how to do it. And but there you go. We've got 3 charts overlapping each other to give you the lower confidence interval and the upper confidence interval on a normal distribution. So that concludes this video. In the next video, we're going to be talking about adult male heights. So I hope you decide to watch it.